very warm welcome to our webinar. This is actually the first time we organize a webinar like this, so hopefully everything goes okay. We've prepared a slide deck where I want to walk you through within the next 40 minutes, and it's about how to efficiently unload containers. So let's take it away. Can you see my screen, by the way? I think so.
Yes, I can.
Yes. Yep. Very good. Before we start, let me first briefly introduce myself. My name is Jos van der Veest. I founded RoboWorks 3 years ago together with 2 companions. Today we actually within RoboWorks we produce palletizers for the inbound logistics, and within that role I will also give this presentation, but it's not a marketing presentation for our own products. It's more a general overview of the market and where we fit into that market. That's what we're going to talk about today. So if we look at the contents for this webinar, first we give a brief introduction on container unloading and the size of the market, etc. Then we would provide you with an overview of the available equipment, and we separated that in unloading equipment, conveying equipment, and palletizing equipment. So we discuss these equipment, the pros and cons, including the cost levels. And then finally, we present an overview of how to implement the equipment and what design criteria are used for the different kinds of equipment. So in general, we hope to give you an overview on what kind of equipment is available and when to use it. So first, a brief introduction. Each year, tens of millions of loose-loaded containers arrive in the ports of Europe, not only in Europe, also in the Americas, of course. Mainly, this freight is coming from Asia, and the containers are like 70 or 80% of the containers are loose-loaded with cartons, and the majority of these containers is unloaded manually still. And as manual unloading is, it's time consuming, it's labor intensive, it's costly, and it's also hard to find the right people willing to do this tedious job. So, the market is looking into automating this inbound process. Well, if you then look at the industries that need this kind of inbound automation, you see the food and beverage importing companies. You see a lot of customers that we talk to also import beverages and food. We see the 3PLs, of course, that typically also process the volume of course, of other companies, especially, for instance, the supermarket chains and companies with a name out there in the field tend to subcontract the container unloading to the 3PLs because it's not fitting their social governance policies, and they would rather have someone else doing the dirty job than doing it themselves. In the courier express parcel market, there's a lot of loose-loaded truck unloading, but not container unloading, but parcels unloading. So these are the main industries where container unloading is occurring, and we see and we feel while talking to customers that inbound automation is the next big thing in intralogistics. right? All picking has already been automated. Dispatch sorters have already been there since ages. AGVs, AMRs are there, but one of the only parts of the warehouses that have not yet been automated is the inbound at the dock doors. And the drivers of this is the availability and cost of labor, social environmental governance policies, and the availability and capabilities of the vision and robotic technologies nowadays. And there's a lot of investments going on. For instance, pickle robots. They got an investment of at approximately 20 million euros in 2022. They now got another investment of $50 million, excuse me, to only develop this unloading robot. Dexterity has raised $140 million. Boston Dynamics is also with their stretch robot investing heavily in unloading equipment. So there's a lot going on here in this market segment. But the question for the end user is what kind of equipment to use, because there's a wide variety of equipment. There's cobots, there's palletizers, there's unloading machines, there's all kinds of conveyor. And that's the question that we want to touch upon today. What kind of equipment to use in what circumstance? Well, as I already explained in the introduction, we separated the equipment in three different functional elements: unloading, conveying, and palletizing. So let's first talk a bit about the available unloading equipment. If you look at the loose-loaded container unloading, you can of course do it manually, and you can do it automatically. And if you do it by hand manually, you can also use a range of unloading tools. And if you decide to do it automatically, there's generally two solutions. There's the conveyor type of pick and pull unloaders, and there's the robotic arm unloaders. And let's discuss these four types in the next 4 slides. So unloading by hand is typically done with 2 operators. One operator in the container who's picking the boxes from the container and placing them on the pallets, and another operator is feeding empty pallets into the container and dispatching the full pallets to the warehouse. Typically, rates of 400 to 500 cartons per hour are achieved, and it takes 5 to 8 hours per container for single or double SKU containers, and much more time for multi-SKU containers, because then the sorting is also required, sorting to the different pallets. So manually unloading typically costs 150 to 250 euros per container, very generally ballpark figures for single SKU containers. But it can be heavy, as we already discussed. It can be very hot inside the containers, up to 50 degrees in summertime, and it can take a lot of time. So this process is typically only favorable when the volumes are limited up to a few hundred containers per year. If the volumes get a bit higher, you can use all kinds of unloading tools. There's several vendors selling these tools. For instance, Goronski has an unloader with a liftable manual platform. Cartomover has the same device, which is autonomously driving into the container, and with a swivelable conveyor belt, it's more easy to place the cartons on the belt. Then we have Tavi, who has a vacuum unloading aid. You have exoskeletons, lifting aids for heavy bags. Typically, the prices of these unloading tools range from 80 to 150,000 euros. And if you look at the business size of these tools, it's mainly the ergonomic advantages rather than the ROI. because implementation of some of these tools does not necessarily increase the throughput rate, but it helps the people to save their back. But there's not always a very clear ROI and business case with these tools. But you know, if the boxes are heavy or the bags are super heavy, and local legislation prescribes that it's just not allowed to carry these heavy loads, then companies don't have any other choice than to invest in this kind of equipment. Of course, big topic nowadays is the robotic unloaders. We've identified approximately 15 vendors worldwide supplying these kinds of equipment. I listed a few here. Pickle Robots, XYZ Robotics, Boston Dynamics, Technica, I believe they're also in the call today. Warm welcome, Bashira. Dexterity is supplying these kinds of robots, Anywhere Robotics, and we have a whole bunch of others, which I don't mention in the slide, but they're there. What we see, because I spoke to quite a few companies that have already implemented either proof of concepts, or first ready to market solutions. Some of these robots can pick 2 boxes per stroke, but typically they pick 1 box per stroke. For instance, the XYZ Robotics, they have 2 robot arms instead of 1, so they can work simultaneously, increasing the throughput capacity. Technica has a solution that pulls in the cartons with vacuum cups and can also produce multiple cartons per stroke. Effective capacity that we hear is approximately max 500 per hour. At GXO in the Netherlands, Boston Dynamics implemented the stretch robot, who effectively did only 350 cartons an hour. So the unloading rates are not yet where they should be, because of course you're looking at, you want to have it at 600 or 700 or 800 per hour. But the market is developing very quickly. So I expect that within the next couple of years, these robotic unloaders will mature even further and will be capable to produce high throughput rates. For pricing, you have to look at 300 to 500,000 euros total cost of ownership in 3 years. That's the prices that we hear out there in the market. Then you have another kind of unloader, the conveyor type of unloaders. Bastian has developed this Ultra Blue, which is a mobile robot with a swivelable conveyor arm with vacuum cups on the end. Then we have the Mujin Truckbot, which is more or less the same concept, but then mounted on a extendable conveyor. The Truckbot 2 is also a mobile device like the Ultra Blue of Bastian Solutions. Then we have a cargo picker, which is more or less a mini crane that can pull in bags on a conveyor belt. We have Copal Handling Systems from the Netherlands, who has developed more or less a crane arm that can pull in multiple cartons at the same time and then drop them on an extendable. So these are some other exotic solutions that have typically a bit higher capacity than the robotic unloaders, but also higher footprint and typically also come with higher investment cost. So for typical solutions, especially for bag unloading and for high-speed unloading, these solutions might be the right choice. A very important topic is the carton quality, especially when using vacuum cups. To illustrate this, I would like to show you this funny movie of Chinese people loading containers. They have all various techniques to put in the boxes here. They're even hammering it in the container, but I believe it gets worse. Well, this guy, he's sweating because it's 50 degrees. Here they're using a pneumatic or hydraulic jack to compress the cartons. You even see that the roof of the container is totally deformed. Well, as you can see, containers that are loaded this way are not it's not feasible to unload them with automatic robots, because it's just too compact and too condensed. The robots with the vacuum cups will not be able to handle these cartons or these bags. Apart from this, you sometimes have humid cardboard boxes in the container. You have compressed cartons. We see cartons with straps that sometimes cannot be handled, but also nets, and I will show you that in the next slide. Here's a few examples of containers loaded in reality. These are actually our own pictures that we've seen in reality. So some containers have been loaded with nets. Some are cascade stacked, so you can only pick up the top box, because the box below is semi-covered by the box on top of it, and that, so it's a staggered configuration. So the robot really needs to reach out for the bag at the very end. Here, there's poorly glued, wet slip sheets between the cardboards. So all these situations prevent automatic unloading from happening. So it's very important when you select your unloading equipment that you also look at the process quality, of the quality of the goods coming in. Okay, so far about container unloading. Let's now briefly discuss conveying. Conveying is typically necessary to actually decouple the unloading process from the downstream process. So typically the downstream process at the inbound side of the dock is pelletizing, but sometimes the goods can also be automatically injected in some sorting system or in some other automatic handling system. But therefore the need is therefore we need conveying technology. Typically we can look at gravity conveyors and powered conveyors. And if you look at gravity conveyors, you have these straight unloading conveyors and curved conveyors, which are the flexible conveyors. And if you look at the powered conveyors, you also have the flexible roller conveyors, but then with motors, and of course the belt telescopes. And each of those conveyors have their own specific range of application and also their own price level. So let's discuss these in the next few slides. So the gravity conveyors are the simple and low-cost solution, especially for multi-SKU manual unloading. So you have one guy in the container unloading the cartons onto the gravity conveyor, and you have a few people at the other end of the conveyor manually sorting the cartons with their eyes by looking at the barcode or the box color or whatever, and picking the right cartons from the roller belt and placing them onto the right pallet. Typically you have a horseshoe configuration at the end side of the conveyor. There are conveyors with rollers and with skate wheels for the different applications, especially for lightweight cartons. The skate wheels work properly, but this is the low-end solution for low volume and for low volume operations with not too many SKUs. Then, of course, we have the flexible roller conveyors. They're available in powered and non-powered versions. The non-powered versions typically have split rollers to accelerate parcels more easily, and the skate wheels. And the powered roller conveyors typically have single roller with sections of 1.25 meters per section. And these flexible roller conveyors, they can be stretched, so extended and compressed. But something you need to look after is that the contraction ratio is approximately 1 to 2.4. So that means if you want to unload a 40-foot container, you need at least 12 meters of extension length within the container, plus maybe 2 or 3 meters extension length on the dock leveler. So in total, you end up with 14 or 15 meters extension length. But that means that your contracted length is also 8 or 9 meters already. So that means that your connection of this flexible roller conveyor to your downstream system is already 9 meters inside of your warehouse. So typically, these flexible roller conveyors, they consume a lot of space on your warehouse floor. If you have the space there, they might be a cost-effective solution. If you don't have the space, you might want to look at other types of conveyors. The prices of these conveyors range from 10 to 40,000 euros, depending on whether they're driven or not, and of course, depending on their length. Then if we look at the telescopes, they're already out there for decades. There are a lot of vendors out there producing and delivering these conveyors. We have Van der Lande here in the call, who also has a wide range of extendables, but I think that they only use them within their own integrated systems. We have Loadermaster, we have Bude who produces them themselves. We have FHM, we have Newland, we have, of course, Caljan, which is probably the market leader here. Sovex from the UK. These conveyors are typically used in the courier express parcel market, but they're also very suitable for bag unloading. Much more suitable than the roller conveyors. These telescopes, they come with several options, like rail mount, that you can move the telescope from one dock to the other. Drop snoot, which is a Caljan term, but they have a swivelable end effector and conveyor belt that can move up and down, left and right, to make the operator more easy to load the cartons onto the telescope. We have man riders, where the person in the container can ride up and down with the telescope that has also height adjustment. And the prices more or less range from 50 to 120,000 euros, depending on length and of course the options that you select. But in general, very proven technology and widely used in the industry. So if we conclude on conveying, then the following considerations, the following things you need to consider when selecting the right type of conveyor for your unloading operation. Of course, the throughput capacity is important. Typically powered roller conveyors, as well as the telescopes, have the highest throughput capacity. You have to look at the presence and the type of unloading and palletizing equipment. Typically, when you have palletizing equipment at the end, you want to connect multiple docks. So in that case, a flexible roller conveyor might come in handy because you can easily drag it from one dock to the other. If you want to also unload bags, in that case, you might want to end up with the telescope on wheels or on track. Another consideration is the available floor space. As I already discussed, the extendable roller conveyors have a high contraction ratio, which means that the connection ends up in the back of your warehouse. And of course, product type. Are we unloading bags? Yeah, you end up with a telescope, and if you have very high weight boxes, also the telescope might be the best solution because it can move up and down, in that way helping the operator to load the cartons on the belt. So generally, gravity conveyors are most suitable for manual unloading of boxes, especially boxes less than 15 kilograms and boxes that are easily conveyed, so no bags. Flexible roller conveyors are probably the right choice for transport to pelletizing or other downstream equipment. And telescopes are specifically useful for heavy boxes and bags and in the courier express parcel market. Okay, so that's it for the conveyors. Now I want to briefly touch upon the pelletizing topic, because a lot of goods that arrive in the warehouses need to be pelletized. As I already explained, some goods are injected into other automated systems like sorting systems, or maybe via conveyor systems to an automated storage and retrieval system, or some other kind of goods to person system, or AMRs. But the majority of incoming goods will first be pelletized to be placed in the warehouse in bulk before it's being picked and distributed within the hinterland. If you look at pelletizing equipment, I tried to categorize it a bit. Manual pelletizing, of course, the most easy form. And then we have automatic pelletizing. And if you look at automatic pelletizing, we can distinguish between cobots, collaborative robots, which are safe to collaborate within the presence of human. And we're looking at the industrial solutions like industrial robots and high-level or layer pelletizers. The latter two are more advanced, more high-speed, more industrial installations, but also come with their own disadvantages like footprint and cost. And if you need to pelletize a wide range of SKUs at the same time, for example, because the container that you receive is not snake loaded but randomly loaded, you might need a buffer deck. And the buffer deck you typically see only with the industrial and the high-level pelletizer types. I will discuss that in the next few slides. So if you look at manual pelletizing, it's probably the right choice for low to medium volume operations with just a few SKUs. With less than 2 SKUs, you can just pelletize inside the container. You just place two empty pallets in the container, and the guys unloading the cartons, they already have it in their hands, and they sort it to the right pallets. And another guy is supplying empty pallets and dispatching the full pallets. If you have more than 2 or maybe 3 SKUs, it takes quite a lot of space inside the container to place these pallets. So then the operator needs to walk to and from the pallet, which drastically decreases its throughput capacity, its productivity. So then you might want to pelletize outside the container. So convey the parcels from the container with a gravity conveyor or powered conveyor to outside the container. You can see it here in the picture below. You have a setup with 5 or 6 different pallets, and you separate the unloading process from the pelletizing process. Typically, production rates of 100 to 500 per hour are seen. I've been talking to a customer who only produced 73 cartons per hour per person manually, just because the containers that arrive had an average of 25 SKUs. So they needed a lot of work and a lot of manual sorting, a lot of walking, and then your productivity ends up below 100 an hour, which is really poor. But there's, yeah, it might be the right solution for low volume operations with less skill. But of course, the downsides are the labor cost, availabilities. Are these people available? Injuries, ergonomic risks, and of course, possible sorting errors, poor stacking quality, wrong patterns. There's a lot of downsides on manual pelletizing as well. Here you can see a very inefficient manual pelletizing operation. There's 4 guys hanging around with their hands in their pockets, sorting the cartons to the right pallet. This specific container also had more than 10 SKUs inside, so this can be a headache, both from operational and from financial view. If we look at cobots, they're widely available. There's many vendors supplying cobot cells. Typically, they do 400 strokes an hour, maybe a bit more, maybe a bit less. Sometimes they can pick up 2 boxes, but typically always with vacuum. And that's where I also want to warn you that vacuum is the perfect tool for high quality boxes. But that's not always the reality in inbound logistics. Sometimes you get wet boxes, you get straps, and then vacuum might not be the right tool for pelletizing. But it's a cost-effective solution for medium volume operations with high carton quality. So it's definitely worthwhile considering. If you then look at industrial robots, there's also a wide variety of vendors supplying them. Here's a few typical layouts. How it works: you have 1 or 2 flexible conveyors. We have a scanning station, and then we have a sorting belt that sorts to, in this case, 6 destinations. And then we have 2 robotic arms that can pick up cartons 1 by 1 or maybe 2 by 2, and placing them on, in this case, 6 conveyor belts, pallets, pelletizing locations. And then we have a T-car behind it who collects the full pallets and maybe pulls them through a wrapping station. Oh, sorry. So this is typical setups of industrial robotic pelletizing cells. Typically, a robot can reach 3 or maybe max 4 pelletizing positions each, depending on its size. You also have translating robots. They can reach up to 10 pallet positions. If you make the track longer, it's the throughput rate drastically decreases. And in this way, you can typically pelletize 500 to 600 strokes an hour. But still, most of these solutions work with vacuum, and you have to really make sure that the carton quality suffices for vacuum pickup. Here's a few examples that we've seen in reality why vacuum is not working. You can see compressed boxes, which have a different height than you expect. You can see poorly glued boxes. You can see wet cardboard boxes that have been sitting on top of the container, collecting moist during their 6 weeks sail on sea. Then we have these round boxes. We have compressed boxes that have been sitting below in the container with heavy weight on top of it. We have porous cardboard where the suction cups just suck the air right through the cardboard, unable to pick up. You have display boxes with a perforated lid, and if you pull them up with a vacuum robot, you have the perforated. You grab the perforated lid, and the box stays on the conveyor. So we have built our own vacuum robots, and we have learned that vacuum is typically not the right solution for inbound logistics. Only when the carton quality is high And but this is something you really need to test before investing in vacuum pelletizing technology. Another technology that is out there is the layer pelletizers. They're robust, reliable. They can handle poor carton quality and have high throughput rates. However, they have a large footprint. They're typically inflexible and very costly. Typically more than 1 million euros per piece. And they include a big footprint. So if you have the space, this might be the right solution. But there's some downsides of it. And sometimes you also might need a buffer deck, especially for multi-SKU containers that are random loaded. This buffer deck also takes a lot of space and a lot of cost. Now I want to very briefly touch upon our solution that we've developed for overcoming this problem. We have developed a multi-SKU layer pelletizer that can handle, that doesn't need a buffer deck because we have in this case 6 pelletizing positions where it can sort to. So at the infeed we have this lift where the cartons are being transported from transport level 800 millimeters to the high level of approximately 3 meters. With pushers, we then create rows on a central belt conveyor, and these rows of cartons are then being pushed and sorted to the right pelletizer. In this case, we have 6 pelletizing positions. So the cartons can be mixed. There's a mixed flow of cartons from the container can be processed by this machine, and each pelletizing position is building its own layers. And when the layers are complete, the plates open and the items drop onto the pellet that is suspended in a lift. And when the pellet is complete, it's being transferred to a central roller conveyor, to a wrapping automatic wrapping device. Also, the pellet label is applied, and then the completed pellet is shipped to the pellet outfeed. So in that case, you have the full functionality that you need on the inbound dock, except for the unloading. But there's 15 other vendors that supply the unloading equipment. So we believe that this solution might be the right one for a lot of inbound operations. So far with the commercial talks, let's conclude on pelletizing, and that will also be the conclusion of this webinar. I see that our time of 40 minutes has already expired. So if we conclude, manual pelletizing is typically for low volume operations up to 400 containers an hour, limited to SKU and number of SKUs and weight, and all carton qualities are allowed, of course. Cobalt pelletizing might be for medium operations the right solution, but you need a very high carton quality. With robot pelletizing are typically suitable for high volume operations, with a medium and high carton quality is required. And with high level pelletizers or layer pelletizers, also for high volume operations, but the buffer deck is required typically for multi-SKU operations. And these two, robot pelletizing and high level pelletizing, we have our own solution for that combines this functionality and into one machine, the multi-stack. And to conclude, I have this slide, which is in fact a decision support diagram that companies can use to select the right equipment. I promise that not all arrows end up at our own machine. I tend to we try to build this graph based on the business cases that we've built as logistic consultants. And we look at the weights, we look at the if it's snake loaded or not. We look at if it needs to be stacked on pallets or not. And of course, this is not exact science, but this is in the end more or less a high level decision support tool to select the right equipment. If you need to know more about this topics, please reach out. I will share this deck as well as the recordings of this webinar to all the attendants. And if you want and if you have the time, there might be a moment for some discussions after the call, but I can also understand that your time is limited and that you need to go to your next meeting. But I'd like to thank you for attending this webinar, and hopefully to see you next time in one of our webinars, or to talk to you in the meanwhile. Thank you.